So hello there and welcome back to another tutorial, and today I'm going to show you how I created the scene you just saw. In the viewport it looks like this, and the basic setup. And before I go into more details, I want to point out that I was really inspired by Marcus Gonza 3D, who created this effect and tutorial in Cinema 4D with After Effects. And I just thought to myself how I would do this in Houdini. So I'm going to show you how I did this. So let's go over the scene and show you what you're going to learn. So I'm going to show you how this growth setup is created, or this infection setup. It's going to be art-directable, so you will be able to paint where you want the growth simulation to go first. So you can guide it a little bit with these lines. And I'm going to add some noise to it. And you can also choose where this growth should start. You can also create a custom shape and input it there, so it could like grow from a logo, for example. And then we're going to use this to create like an outer ring that will drive the plant growth. And in here, and we are able to also change the width of this outer line. So right here we can change this, and we can also change the blur amount, so growth is smoother or less smooth. And then we're going to use that to scatter some plants around, and then we're going to be able to also control the height of this outer ring here and the width of this, like I showed you before. And this growth effect can be applied to all kinds of meshes, so you could also import your own 3D assets, mesh them together, scatter points around, and have those plants or whatever you want to do with it grow over different types of geometry. So it's not restricted to just a plane. So let's get started. The first thing I want to do is make this dark. So if you hit D, you get the display options, and then you can, I'm not seeing the drop down menu, which is a little bit buggy, but I'm just going to select dark. And then the first thing I want to do is drop down a grid, jump right in, and I want to increase the size. So we'll just copy the first value here, right click, copy parameter, right click, paste relative reference, and we're going to do the same thing for the rows and columns. So I'm going to increase this to 50, let's say, and I'm going to increase the resolution as well, say 200, so we have something to work with later on. Next up, I'm going to drop down a UV project so we can add some textures later on. And that's all we need to do for a plane. And then I'm going to drop down a mountain sub and just change this to something you like, or keep it flat, does not really matter. Next up, we need some points to be scattered on here, so I'm going to use a scatter node and add some more points to work with. This is looking good. And then we want to group the starting points. So I'm going to drop down a group node and change the group type to points, disable the base group, keep in bounding box region, and I'm going to use a bounding sphere. You could also use a bounding box, bounding object, and then you could wire in your custom geometry here. And the group name will be $OS, which stands for operator string. So the group name will be the name of this node. So as you can see here, we have a point group called group 1, but we want the name to be start, for example. It doesn't really matter too much, but something that makes more sense. And it's called start. Alright, next up we want to drop down a wrangle node. Point wrangle to be precise, so make sure you're running over points. And then select the starting group start that we just created. Next up, I'm going to add a float value to those points. So we do this by typing in f@, to create a float attribute. And that attribute name is going to be infection equals 1. Okay. Next up, I'm going to drop down a solver. And this runs over multiple frames, so we don't have just a code that's executed once, but every single frame. Just hop in here, and I'm going to drop down a wrangle node. All right. So we could just start typing in right here, but I'm just going to pop out an text editor, and you can do this by hitting Alt-E, and then you will get this nice editor, which makes it a little bit nicer to type in. So the first thing we want to do is create an if statement. So if f@infection is smaller than 1, we want the following code to be executed. Okay, so we want to create an array to find those points that we want to work with. So an integer, I'm gonna name that array. To initialize an array, we have to do these square brackets equals, we have to find those points, and there's a function to find points and put them in an array called pcfind. And the way to work with these kind of, or with functions you don't know, you can't remember, or you just don't know, or you just have to remind yourself once in a while. I have to remind myself all the time how to work with those. You can just, if you're on the word or on the function, just hit F1 and the help menu will pop out. And here everything will be explained on how to use this. And luckily we already have everything written for us here. So there are other tutorials which explain really nicely how this works out there. But I'm not going to do that because I'm probably going to make a mistake. So I'm just going to translate this on and say how to use this. Alright, so we already created pcfind. And the file name will be 0. Since this is the first input we have, you could also use operator syntax, so you could use a string and reference some other geometry you have somewhere else. You could do that, but in this case we just want the first input, which is 0, and the second input is 1. But yeah, we want 0 in this case. Next up, we want to define over what type of geometry it's going to run over, and we want what kind of, wait, let me check. The P channel in this case, as you can see, it's really helpful. I have to read. Yeah, so it's going to run over the point positions. So the P channel, and in this case, it wants it as a string. So P. And next up, we want the attribute position at P. And next up, we want max distance and max points. So max distance will be a float, and as you can see right here, yeah, max distance is float and max points is an integer. And we could just type in numbers, and those would be static, so every time you want to change them, you would have to go in there and make a change to the code. But there's a nicer way to do this, and we can create ourselves some sliders, which is fun and easier to work with. So first up, we need the max distance, which is a float value. So we're going to create a float value just for this sub. So we're not going to add an add attribute. This creates an attribute which down the line will be usable. So if you create a attribute wrangle here and you want another attribute wrangle here, it would carry on that attribute that you create with at, which we did with f@infection. So this attribute is carried on. And if we create just a float value, it will not be carried on. It will just be used in this one instance of the wrangle sub. So this is going to be called max dist, and that will be equals to the channel float we want to create. So channel float creates a UI slider, a float UI slider, and we have to name this. So I'm going to name it max underscore underscore creates a space in the UI, max distance, and next up we want an integer called max points equals channel integer max underscore points. All right. And now we can just replace this. So the max distance will be here and the max points will be here. And next up, we have to create this p-value right here, which is just a way to expand or write out the array values and use them. So I'm gonna name it. It's gonna be a float, and I'm gonna name it growth. We have to give it a value of 0, and then we have to create a for each function, which will run over every item in that array, or every point in that array, I should say, because there are points in that array. And it needs an integer, ptnum, which is basically like a counter for the array to say at which point we are at. So I'm going to name this array counter. And we want to run over our array called array. And then we need some curly brackets. Alrighty. And here they're running over vector data, but we just want to run this over float data. Since our infection is just a float value, we don't need much more. So we need a float value, and this value we're gonna call infection growth. Infection growth. Okay, and that is equals to point. So we want to read out point data from the point we're at in the array. Again, it wants the file name, so 0, first input, and then we want to run over the attribute in a string form, and we want to run over the infection attribute we just we just created. And lastly, we want the array counter, so this function knows where in the array we are. So array counter. Close this up. And then we need to add this to our growth float attribute. So growth plus equals, which adds to, and we're going to add the infection growth to that. Close this up. And in here, we want to divide the value we're adding to by the total amount of array items. So len returns the total amount of items in that array. So for this, we need to create a float value to divide this. So float div equals p, so in this case growth, divided by len array. Close that up. And now we want to add we want to add the growth data that we just had to our infection attribute to use that later on. So f at infection plus equals div. Alrighty, perfect. Apply and accept, and we need to create these UI sliders we wrote in here. So by clicking this icon up here, Houdini scans the code, and then if it sees this, it will create the sliders like so. And then we just have to type in some values. So the max distance will be 8 in that case, and the maximum amount of points will be 25. And with this, you could also increase or decrease the speed of the growth. So if you just turn this up, it will of course find more points in a larger distance, and it will progress faster. So this is your speed control basically. And I'm going to save this now before it crashes, because that sometimes happens. And we don't want to lose our work. So you should always save stuff out so you don't lose your work. It's really frustrating if it happens. I'm just gonna name it number 2. Whoopsie, what's this? Okay, accept, perfect. Next thing we can do is to bring these values out of the solver, so you don't have to dive into the solver every time you want to change these two values. The easiest way to do this is to split this view. So just click on this little drop down here and select split lane left right, and then just pin this so it stays there even if you go out. And if we're here, we can change, or we can edit the parameter interface right here. So this is how we add things to it. And the reason why we pin this is so we can just drag and drop these two values. Then apply and accept. If you close this, you now have these two values up there, and you can type in whatever you want. Oh, and one thing, edit parameter interface again. If you click on these values, you can increase the range. So for example, for the max distance, we don't want it to be 0 to 1, maybe like 0 to 100, doesn't really matter. You can choose whatever works for you. And for max points, we also want a little bit more. So I'm just gonna say 100 and just hit apply and accept. And then you got some sliders that actually are usable. All right. And now we can see if what we just wrote actually works by dropping down a wrangle node, attribute wrangle, and then setting a color attribute. So at cd equals set. You use this function if you want to add to that attribute you're currently writing to with another attribute. So this is why you use set. So f at infection, and then just for the red channel, and the rest is going to be 0. You could also use it on all channels, and it would be white. Okay, as you can see here, we can see it's red, and if I play it, it works great. And now it's playing faster than normal, and if you select this time icon, it will run in the proper speed, or the right speed that you set. So I think I have 24 frames per second. Perfect. So this works great. And like I said before, if you just copy this to all values, it will be white, since yeah, if you want to have white RGB values, you just have 1, 1, 1. And in this case it is like that. But you probably you save storage on a really large simulation if you just write in one value, I guess. Not quite sure if that actually happens, but yeah, red is also cool. Well, whatever. You could also make it green or blue or whatever color you want, basically. But I like white in this case, so I'm going to leave it at white. Next up, we want to create the Art-directable part, so the paint attribute. For this, I'm just going to drop down a null here to make it a little bit cleaner. Call this in. And then just drop down an attribute paint node. Activate this. We want to write, or you could just leave it at mask, but I think multiply makes more sense because we're actually going to multiply this with the infection value. So I'm just going to call it mult. And if you hit enter in the viewport while having this selected, you now get a brush, and if you scroll up and down, you can increase or decrease the brush size and then just paint the forms you want to have. And here you can reset all changes. So if you want to paint something new, just reset it there and paint whatever your heart desires. Small smiley, because we're all happy. Next up, we want to add some noise to this, so it just so it grows a little bit more natural. For this, I'm going to use an attribute noise node. Here it's set to CD, but that's good for now because we want to see what we're doing, and then we can change it. I want to remap the noise to not make the noise the strongest part in the chain, so the attribute paint can still work its magic, so to speak. So I'm just gonna decrease or increase the minimum value to 0.1 and the maximum value to 0.2. So the noise only slightly influences this whole system. Gonna increase the element size to something like this, and then change the attribute to alt, because that's the attribute we just created and we want to change it to. And everything else is fine. You could probably change this to 1D, I guess. Should be fine as well. But it works fine in 3D, so I guess it really doesn't matter too much. And then we need to transfer this value we just created to those points. And we want to do this right before the solver. So here we're going to drop down an attribute transfer and transfer our value. And here we want to change the source group to points and the destination group to points as well. We don't need primitives, we need the points. And our attribute is mult. Alrighty. And we can check if the attribute noise works with the attribute paint or if the attribute transfer works. Oh, if the attribute noise works, I just want to test it here by hitting X for dropping down a visualize node. It automatically goes to the attribute P. So under visualizers, you can change the attribute to whatever attribute you want to visualize. In this case, it's mult. And as you can see here, we have like the smiley is a little bit faint, but I think that's alright. You could, oh yeah, that's because this reset. So actually good that we checked, because I still want it to be at 0.1 to 0.2. And as you can see, this makes more sense since the growth is going to happen, or the painted parts are going to be more influential. Alright, so I can delete this visualize node. Ooh, Houdini just froze, but all good. Save, that's why we're saving, because weird stuff can happen. Right, and let's see how it looks with our... Ooh, yeah, so it does not do anything because we didn't change anything in our code. So we need to dive into our solver again and then add or multiply that value right here. So times mult, at mult, because it's an attribute, float value, f at mult. All right, and now it should influence it, and it's doing just that. There we have it. So if you want this to be a little bit more apparent, then you should probably choose starting points. You can also have multiple starting points or multiple start groups. You could just add So union with existing, you could just add multiple of these nodes and have more starting points. So if you like put the starting point here, for example, and then go back to attribute paint and just check where it is. So I could just template this here with this on this icon. You can template a node, or with W, so you can see where it is. I can't really make it out there. You can see it there a little bit. So I'm going to reset the changes, and I want the smiley to start from here, for example. And if you do this and just deactivate the template again, it should grow more apparent in that direction. So just choose your starting points right. Yeah, and play around with the settings until you find something that you like. All right, so now we have the basis of this whole thing, our growth. Now we have the basis for our growth simulation. You can use this for more things, other things, but we're going to use it for our setup. And the next thing we want to do is to transfer this back to our plane, or to our original geometry we scattered the points on. So I'm going to create an attribute transfer once again. And I think that's wrong. It needs required. So there's going to be the geometry to transfer attributes from this here. And we need the geometry that's coming from here. So if you just click here, click Alt, it will create like this reroute point. Makes it look a little bit neater. It already does this, but we want to specify it. So we're going to set it to points and points, deselect primitives, and then select CD as our attribute we want to transfer from. All right, and this works well. And as you can see here, the values are not probably going over 1, since we are multiplying that value. So it's, if you transfer those values back to color data, it's probably going over 1, and that's why it looks a little bit weird. And there's a really easy way to fix this, and we can do this in the point VOP node. So drop down a point VOP, dive in, connect the color with the color, so CD to CD, and drop down a fit range node. Could also do this with Vex, but this is way easier, and this is working already, but to be sure, just set it to RGB color, so it's working with the right data. Should be also fine with 3D vector. All right, so now we got this set up. And now I'm going to show you how to create that outer ring we spoke about earlier. And this is quite simple. We just need to time shift this by a certain amount of frames and then subtract that from the main item. So we create a smaller version of this and then subtract that. And that's really easy to do. We just drop down a time shift node and just hit Control Shift and click on this. So we'll delete the animation that's automatically created here. Type in $F minus, let's say 30 to start with. Okay, as you can see here, it went back 30 frames in time. And now we need to subtract this from the original growth. It's also really easy to do. We could do this in VOPs, but I find it quite easy to do in a wrangle sub, so another attribute wrangle. And then we need to get our original color data, so at CD minus, so that's gonna minus that incoming data from there. We want to actually have the original geo and the original information in the first one, and the time shifted version in the second input. and we want to grab the second input. So the way we do this is we have to specify that it's a vector since it's color data. So v at operator input. So op input 1 underscore cd. And then it's just going to use the input 1, so this is the second input, to subtract this from the main one. And this is looking a little bit jaggy, and there's a really nice node to blur this. It's called the attribute blur. So attribute blur. And here we can just blur this. Oh, right now it's blurring the position since the attribute is set to P for position, but we want to blur the color data, so CD. Great. And now we got this nice effect, and as you can see here, it's jumping since if there's nothing to subtract from, it's going to create negative values, and we can check this by splitting our viewport from top to bottom, like so. And then just go to inspectors and select the geometry spreadsheet, and here we can see what's happening. And yep, I was right. We're creating negative values and we don't want this. So I guess there are multiple ways to do this. We could create a point VOP, for example, I think. So point VOP, jump right in there and go from color to color and drop down another fit range. And that should work out fine. So now it's not negative. And another thing we can do, since our wave jumps into existence, and this can lead to some problems later on. As you can see here, if I switch back to our main thing, it already exists. But if I go back to our wave, it just, it just jumps into existence, and we can make this transition a little bit smoother and avoid future problems by just switching between this and the wave version by dropping down a switch node and piping this in and type in $f if that's bigger than the current number. So let's say 30, because that's what we use in the time shift. And we can also synchronize these two, so we don't have to always change both of these values if we change one. By creating a controller, and we can do this by dropping down a null and then go to edit parameter interface once again, and we just need an integer. So right here is an integer. We can drag this in here, rename this to, let's say, wave offset, and increase the range to, let's say, 100 again. Hit apply, accept, and now we got the wave offset. I'm just going to copy this parameter, copy parameter, and we can just select this, right click, paste relative reference, and then we're going to have the value that we choose here. So the offset value is going to be controlled by that controller, and we can use that same value to drive the switch as well, which is really helpful since we just need to change one value and not two. You don't have to think about that later on. It just makes a lot of stuff easier. All right, so this should work. And as you can see here now, the transition is way smoother and should help us prevent weird glitches later on or down the line. All right, I'm just gonna make this a little bit smaller, but keep it open. Maybe we're gonna need it. And I'm gonna create another null for the main simulation. And since we want, or in this case, I want the blurs to be the same, so we don't have to think about that. I'm just gonna copy this blur over and copy the blur iterations from here. So copy parameter and paste this in the other one. So again, we just have to control one value, and if you would want to go one step further, you could do, you could add the blur iterations to this control as well, so you have it more streamlined, and you could even add the solver controls to this null just with the same technique I showed you. So you just have one null to control everything, and later on you could also package the whole thing together and use this null as the starting point to create your Houdini digital asset, or HDA. But I'm not going to go over this. This is just a basic setup. All right, so this I'm gonna call main main growth, and I'm gonna drop down another null for here. Oopsie, and call this wave growth. Oh, and by the way, Houdini sorts everything that has capitalized letters and puts them at the top if you search for them, if you're referencing them. So I suggest actually capitalizing your null outputs. So I think out main is probably a better naming concept, and out wave. All right, that's cool. Okay, so now we got this set up, and the only thing we need to do now is add some plants that are going to use the growth setup. And for this, I'm going to use Quixel Bridge and Quixel Megascans. You can use whatever you want, but I'm going to use this. And let's look for a plant I like. So I think I really liked Lily, this Lily of the Valley. Really like this one. So I'm just gonna export this to Houdini. Start my Megascan plugin. So you have to start it first and make sure you have Megascan scattering enabled. Great, now you can close it. It's already initialized. Export. It's gonna take some time. If you don't have the textures converted already, but mine is already done. And it jumps straight into the imported assets, and we don't need the imported assets, we just need the scattered setup here. And from this setup, we don't need these things. You can just delete them. We only need these three things. So the Quixel simple scattering. Oh, we actually also don't need the grid. So we actually just need the source objects and the Quixel simple scattering node. So the first thing we want to do is we want to retrieve our object we want to scatter this on. So our plane. For this, we need to drop down an object merge and then link the whole thing up with the thing we want to scatter on. So in this case, out main. Perfect. Save again. And then I'm going to drop down a copy to points node and wire this up. And right there, we're already scattering. And now we need to make sure that the p-scale value is being controlled by the color value right there. Right. And for this, we're gonna need an attribute transfer. Since Quixel simple scattering does some weird stuff, and the color data is not being transferred from the object merge over to here. So we need to actually transfer this, which is a little bit weird, but I was also struggling a bit to find this out. So we just need to drop down the transfer node here, and you could just connect this up. But to make this a little bit cleaner, I'm going to copy this node and do this, so it's a little bit nicer to look at. And right now just the color data is being transferred. As you can see, it's I'm just gonna increase the P scale a little bit so you can see what's going on. Yeah, so the color data is being transferred, but we want to actually have the color data influence the P scale value, so we get this growing effect. And we want to specify what's being transferred first to be precise. So we want point data, and we want the attribute CD to be transferred from points to points. Okay. And a really easy way to do this is to drop down attribute wrangle once again, run over points, and then type in add P scale. So this is our scaling value, scaling attribute. And we want to multiply this by the color value that's coming in. So add CD. And if you just type in add CD, it's just gonna use the first value. So if you left it on red, for example, I can just show you how this is. Oh no, I'm just gonna leave it at that. But for example, if you just had, if you didn't make it white and you left the infection value on the first number and the other ones left on 0, then you could just type in cd.r and it would just take the first value, it would just read the first value, or you could type in .g for green or .b for blue. You would select the blue channel. But we just need one value, the first value, so it really doesn't matter in this case. All right, so this is working. And as you can see here, our setup is already functioning. So we are basically almost done. We just need to add the wave effect to our growth system. And this is also quite really easy because we already have everything we need. We just need to copy this whole setup and wire it up. And then just change the out main to our out wave. So we're getting those color data from the wave. And then instead of multiplying this, add this. And that's basically it. And if you want to control this a little bit more. Oh, and by the way, this is getting a little bit confusing when the plants are also using the color data. We can avoid this just by either deleting, we can avoid this by either deleting it right after here, so dropping down an attribute delete, but there's a cleaner way to do this. And in the copy to points node, we can specify what values should not be taken with. So this star sign means all values, and this symbol says accept these values. So we can just copy this here, add it to here, and instead of V for velocity, we're gonna use CD for color. And then it's not going to use those attributes to drive, to copy this over. One other thing you want to enable in the copy to points node is pack an instance. So while rendering, it will be more efficient since it's just stores one instance and not multiple versions or multiple geos, but it's just one instance which is being copied. So it saves on memory. If we go one up, we also need to enable under Redshift OBJ, so under the object parameters, we have to go to the instancing tab and enable instance sub-level packed primitives. This will enable your render times a lot, like I think for me it went up. It was 6 times faster, something like this. Probably depends on how much stuff you're scattering, but this is really important if you want fast render times with this setup to have that enabled. And for some reason, Quixel does not enable this, so if someone from Quixel is listening, maybe this should be on by default, or maybe there's a specific reason why it's not enabled. I'm not quite sure, but yeah, it cost me quite some time to find this out. Actually, I was quite happy when I found that checkbox right there. All right, and if you want more control over this first wave of this growth wave around your growing objects, we can just create a multiplier. So multiply this by a channel float value, and I'm gonna call this wave multiplier. And we need to enable this right here. Oh, I capitalized the C, it has to be small, so channel float. Then we can enable this. And then if we can control the growth a little bit more, way more. Ooh, I hope Houdini is not crashing right now. Oh, it crashed. Oh well. Oh, happens. I'm just going to open the file again. Luckily we saved it. Sorry. But as you can see, this kind of stuff happens from time to time. All right, and we didn't lose too much work. Yeah, we got everything. Perfect. So I'm just gonna enable this first. Yeah, so on the Quixel simple scattering node, you can now change how much stuff you want to scatter, or the p-scale value, play with noises, add some motion. This is pretty cool if you add some motion to it. And you can art direct your scene way more. And what you can do, of course, is also just import some other objects and just use the same setup and then layer those on top of each other, so you can have some flowers and some stones or whatever you want to do. And you could just layer this and create something really nice. But for this, I just wanted to show you the basic setup. The next thing we can do, or I will show you, is how to use this growth setup we just created to switch between two materials. So I'm just gonna import one material first, so we can play with that. So I'm just gonna go to surfaces, and let's get this beach sand I really like. Exporting. Oh, actually I have to enable Megascan plugins again. Alrighty. Okay. Perfect. And a really nice tip is if you drop down a parameter node, and then you can select all of the nodes, all of the texture, RS texture nodes, and select the scale input and connect them to the parameter you just created and just name the scale. And if you hop out of this material, you'll now have a scale option, and it's really easy to change the scaling of your material. And I think I already know that I want like something around the scale of 2. Save. Drop this down on your ground plane. And the next thing is I'm just gonna do this really simple. You could just import another material and then use a material blender. Oh wait, what the hell? I'm just gonna show it. We're already this far along. really doesn't matter if I spend another 2-3 minutes importing another material, I guess. So let's yeah, this looks always so hard to choose. There's so many on Quixel. It's crazy. Doing a really good job. Let's use Nordic moss, whatever. So I'm gonna export this. And here we can do the same thing. But first I want to copy this whole set except AO. We don't really need AO, and we also don't need gloss right now. So I'm going to copy this over to our other material. So I type beach sand, just paste this in here. And then I want to create a material blender. So material blender, drop that in here. And then we want to wire this up. So in layer color. And then we want to import our color data. And we do this by getting a RS color user data node. Instead of UV tangents, we want the CD value. Then we can just pipe this into the blend color. And of course, you can also drop down something like a ramp node, and then you could control the contrast a little bit more or add some noise to it or whatever. But this is gonna be the basic setup. And now we can see if this whole thing worked. So I'm just gonna drop down a light dome, select some HDRI, disable it from the viewport, save it. And we need to enable tessellation and displacement on our ground. And I know that we need to lower the displacement scale a little bit. And now we can check if this worked. And this is working fine. As you can see, the ground texture is not looking too nice, but you could add some noise to the to the growth infection. You can make that look a little bit nicer. You can add some contrast to it, whatever you want to do. But this is the basic setup on how to set this up. And yeah, probably another reason why it doesn't look too good is because we didn't use a displacement blender to add to the displacement. See, and you have to wire everything up like so. So you're gonna use the same color data to blend between those two displacement maps with the displacement blender. And you can also use the same scaling parameter, so everything is the same scale. That makes more sense. And now we can check again if that made it look a little bit better. I guess so. But yeah, this is the basic setup. Now you could play around with it, create an animation out of this, or do something completely different. It's all up to you now. But I think this should have given you the tools to create whatever you want to do with this setup. Right, this was a little bit lengthy. I apologize for that, but there was a lot of stuff to cover in this tutorial. Yeah, I hope you enjoyed it. See you guys next time. Thanks for watching.